Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about recursion in Java and how you can use it to tackle some problems. So let's start with defining recursion. So, recursion in computer science is a technique where a function calls itself to solve smaller subproblems of the same type. It can seem a bit tricky at first, but mastering recursion, it's really useful for tackling many problems in computer science. These problems can range from sorting and searching to solving puzzles and like navigating other data structures. So let's start by giving a more detailed explanation of recursion. So, recursion occurs when a method calls itself either directly or indirectly to perform a task. The key to recursion lies in two parts. The first part is your base case. So this is a stopping condition that prevents infinite calls of the function. And infinite calls of the function will not give you the answer that you need. A second part is a recursive case. So this is where the method continues to call itself on a smaller input and it gradually converges to the base case. So to show recursion, let's start by programming a simple example, finding the factorial of a number. So I'll code it and then I'll like explain it fully after. So we're coding this from scratch. So let's import java.util.that just in case we need to use anything from that since it's really common. Next, let's make our class public class. My file name is main, so my class name has to match it. So here we have two methods, our main method and our factorial method. So I'm going to start by making my factorial method. So public static int, since it returns an int, factorial, right? And then we take int n as a parameter, which is the number that we're going to find the factorial of. So let's start with our base case, right? If n is equal to 0, return 1. We return 1 because the factorial of 0 is always 1, right? But then this is the part where recursion comes in. Here we return n times factorial of n minus 1, right? So this is where we call that. This works because the factorial of a number, if I define it, it's just like all the numbers below n including n multiplied. So say the factorial of 5, which is denoted like this, is equal to 5 times 4 times 3 times 2 times 1. But notice what you can do. If we use the same definition, we have 4 factorial is equal to 4 times 3 times 2 times 1. If we substitute 4 factorial for this part over here, we get that 5 factorial. Is equal to 5 times 4 factorial. And this matches this part. So let's say our number is n that we're finding the factorial of. We're returning n, so 5, times factorial of n minus 1. So 5 times 4 factorial. Now let's move on to our main method to actually see our program. So using the normal main method, like an incantation, we have public static void main string args. Alright, so let's say, alright, so we can just print out int, so let's just define an int, right? Int x, let's say it can be equal to 4, right? Actually, no, we could do something else. We could just directly print out like the factorial. So using IntelliJ's built-in shortcut for system.out.println, we can just print out factorial of 5, right? So if I run this, right, it gave us our desired answer of 120. we do it for like, if we do it for bigger numbers, like let's say 9, right? Because factorials, they scale up really quickly. So anything above, like, I'd say 15 or 20 would be pretty large to handle. So yeah, it gives us 9 factorial right there. So let's just kind of break this apart again. This is our base case, and this is our recursive case, making this a true recursive function. So let's use another well-known example of recursive functions. This is none other than the Fibonacci sequence. So let's code that. So, alright, let me just take this out. So we're just going to keep our main method because we have to use it again. And we're going to make a new method. So, it's the way you call it and define it is the same as the factorial, except the name's different. So, let's define it. Public static int, since it returns an int. And it's called Fibonacci, right? And then we also take a parameter of an integer n, because that's the number we want to perform the Fibonacci sequence on. Alright, so let's start with our base case, right? So if n is less than or equal to 1, we would return n, right? We do this because 0 Fibonacci, like the Fibonacci of 0 is just 0, Fibonacci of 1 is just 1, and yeah, so pretty much just saying if n is 0 or 1, return 0 and 1 respectively. Now let's go to our recursive part. So if this doesn't work, right, then we return Fibonacci of n minus 1. Since the Fibonacci sequence is just, wait, let me put this in comments after I do it. Return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So let me just explain the Fibonacci sequence real quickly. So Fibonacci sequence, essentially the sum of the two numbers. Well, I mean, it's not essentially the sum of the two numbers before it. It's like a sequence that goes like this. So for my first term, we can just take 0. My second term, my first term, we take 0 because there's nothing to add. Second term, we take 1 because, like, if we just have 0, it wouldn't really be interesting. Third term, we sum the previous two, so we have 1, and we keep on going. 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 5 plus 3, 8, and so on until it reaches infinity. So that's how the Fibonacci sequence works. So now let's actually call our Fibonacci sequence, right? So we can essentially do the same thing. We can just print out Fibonacci of, say you want to do 10, right? Because Fibonacci sequence doesn't like grow as quickly as factorials do. So let's do that. And we get 55, which, let's just check this real quick. 0, 1, 0, 1, 1, 2, 3, 5, 8, 13, 21, what is that, 34, 55. 0, so this is when n0 ends 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sequence does indeed work. So let's talk about some key concepts you have to remember when you work with recursion, right? So you have to always define a base case, because without the base case, your sequence is going to have infinite recursion. Like, let's say I just remove this base case, right? It would, like, see infinite errors, and you don't want that to happen. So next you have to actually understand the recursive case. It's like how the function progresses towards the base case. Next you have to be careful with large inputs, because like this recursion, it can like increase your space complexity by a lot, which isn't really ideal for programming. Like, let's say I want to take the factorial of 100, that would take a long time and my computer would probably crash. And for problems with like overlapping subproblems, like let's say your recursion it overlaps, so you have to do like multiple separate cases of recursion. Don't use recursion. Actually consider alternatives such as dynamic programming. So, recursion is really useful for problems that involve breaking a task into smaller subtasks, traversing data structures like trees or graphs, and solving puzzles. So, in conclusion, recursion is a powerful concept where a function solves a problem by calling itself. The key is to define a clear base case and ensure the function calls progress towards it. Thank you for watching a Super 7 programming tutorial. See you next time.